Hello everybody. In this video, we will solve an exciting business case. The scenario is that we have been tasked with providing the data science team access to IMDb's primary titles and related information. The challenge? We need to figure out how to fetch and store the IMDb data on Azure so that the data scientists can use it for their analysis. In this video, I will show you how to design a solution for this problem and then actually implement it. Whether you are an architect, a data engineer, preparing for an interview, or just want to see how to solve a technical case study, this video will provide valuable insights.
Hi Data Explorers. This video is divided into two parts. In part 1, I will wear a hat of an architect and step by step will chalk out a solution for this business problem. In second part, I will wear a hat of an engineer and implement the same solution using Azure services. So let's get started.
First, let's wear our architect hats, understand the requirements and design a solution that meets the requirements. Architecture design is a longer process, but for our case study, we are going to use a trimmed down 4-step process to identify a solution. To get started, let's look at the URL that has been provided as part of the requirements. This is the website that holds the IMDb datasets for non-commercial use. Looking through the available files, this is the file that is of interest because it includes field primary title that is required by a data scientist and includes other information as well. As we can see, these files are available over HTTP without any authentication. Also looking at the other characteristics of the file is going to be a zipped file. It is a tab separated file formatted using UTF-8 character set. The first line of the file will contain the headers. These are the important characteristics which we should be noting down because these will be used when we implement the solution. Next, we want to identify the components which are required to implement the solution. So let's bring out our drawing board. Looking at the requirements, we know that the files are present on an HTTP website which is publicly accessible. We need a component that can connect to this website and copy the data over. So that's our component 1. Next component that we need is to store the file that will be copied over. So these are the two components that we would require to implement the solution. Next, we'll compare services available on Azure and see which is best suited to implement our components. Regarding component 1, we require an Azure integration service. Azure offers two services that can be suitable for our use case, which are Azure Logic Apps and Azure Data Factory. To compare the two, you can pause the video and review the comparison. While Azure Logic Apps can provide what we need, it is best suited for automating workflows and responding to events. On the other hand, Azure Data Factory is more data movement oriented and is ideal for creating ETL jobs, which aligns with our requirement. Therefore, Azure Data Factory is a better fit for our use case. Regarding the second component, Azure provides several options for storage such as Azure Blob Storage, Azure Files, and Azure Data Lake Storage. Upon comparison, we find that Blob Storage is optimized for storing objects like images and videos. Azure Files is optimized for use as a shared drive, whereas Azure Data Lake is optimized for storing files for running analytics, which is the focus of our use case. The final step is to synthesize everything into an architecture diagram that aligns with our business goals and technical requirements. The diagram here shows how the data factory will connect to the website using an HTTP connector and then copy the data to the data lake. To keep the video short, we are not going into the details such as networking, access, etc. but capturing at a high level the business requirement, the solution, and the technical details that would be required for the implementation. Now that our technical design is ready, it's time to roll up our sleeves and implement the solution as a data engineer. So there are 6 steps which we'll be executing to implement the solution. The first step is to create Azure Data Lake Storage. So we'll go into the Azure portal, click on Create Storage Account, and here we'll configure all the details. So this is the most important part where we convert a normal storage to a data lake. So I can click on this. So this will make sure that we have got the component for storing the file in place before we actually start copying the files. So I'll give it a minute for this resource to be in place. Now we have our storage account in place, and to store the files, let's create a container. We'll go here, create a new container. Let's name it as IMDb create. And in future there could be more files that we could be pulling in, so let's create a directory within this container and call it titles. And with this we have got everything in place for storage. We have created a storage account and created container and a directory within it to store the file. So before we go any further, just wanted to show you how the file that we are trying to copy looks like. So this is a sample data I've taken from the file. The actual file is 900 MBs and it's very difficult to open the file, but I've managed to take out a snippet of it. The first line, as we can see, is the header, and then we have got tab separated data underneath it.
Next, we are going to create a pipeline using Azure Data Factory. Now, a pipeline is a logical grouping of all the activities that we want to do as part of the job. For example, we can copy the data, transform it, and load it into a database. But in our case, it's going to be a very simple copy activity that we want to implement. So I'll launch the studio. Now here I'll create a pipeline. I'll name the pipeline as IMDb pipeline. Next, I want to create an activity within this pipeline. For our case, it will be a copy activity. So I'll drag this activity across. Now, this is the structure of the pipeline where we have like the general settings. We've got the source, sink. For our case, we are not going to go into the mapping. We'll just specify the source and the sink. So next, we will be working on the source. In the source section, we need to create something which is called a linked service, which will enable this source setting to connect to the HTTP site and extract data. So I'll configure that, a new data set. It is going to be HTTP connection. So I'll select that. Continue. We know it's going to be a delimited file. So I'll select this. Now this setting, as I mentioned, is looking for that linked service that will enable this source configuration to hook onto the source. So this is something that we have to define for our scenario. Here we will configure all the website related details. So base URL of this website, I'll just copy it from the actual site. Now authentication type, there is no authentication required, so I'm going to put it as anonymous. We will configure more settings around it. Here we can specify more details around the file that we are going to pull. For example, we know the compression type is .gz. The column delimiter in our case is /t. We're going to keep the defaults here. There is no double quote character required, so I'll just mention there's no. Otherwise it will put quotes around all the data fields, which we don't want. Escape character, we have not been given any. I'll mention it as no escape character. And of course first row as header, so I'll keep it as is. We want to keep the file as close to the source as possible because there is no requirement to transform the file itself. And with this
we have configured the source settings. Next, we'll go into the sink. Here again, we will configure the storage where we want to store the file. We have already created the Azure Data Storage Lake, so I'll select this, continue. We want to create a delimited file, so I'll select that. Here again, we need to create a linked service. So I'll select my account, storage account name, we created as data via storage. So I'm gonna click create. Okay. Here again, we can open the settings and we can specify more configurable parameters. For example, we created IMDb, a container within this storage, and we had titles as the directory. The file name will be automatically created. Compression type, we want to keep it as .gz. Column delimiter, it is going to be tab. I'm gonna keep the defaults. We don't want any quote letter, and we don't want any escape character as well. So I'll remove this. And of course, first row as header. So with this, we have configured our sink as well. Next, we will be publishing all these changes that we have made. Now, once the changes have been published, we can trigger it. Now pipeline is running. We can view the running pipeline, and there is it. The run is successful. Just to verify, we will check if the file has been copied properly. So go into the containers. We've got IMDb container within that and titles folder, and this is the file that has been recently copied. So with this, we have verified that the file has been copied. Now this file can be pulled by the data scientist to do their analysis. Here is a visual depiction of what we just did. First, we created a pipeline in Azure Data Factory. Then we defined an activity within the pipeline, which was copy data in our case. Next, we created datasets for both source and sink, and while creating these datasets, we also created what is called linked service, which can connect to data stores. In our case, these links were to HTTP website and Azure storage.
So that was the journey from understanding the business case to designing a solution for it and implementing the solution using Azure. If you found this video helpful, do like and subscribe. And if you have any questions for me, do mention in the comments below. Till we meet next time, stay curious, stay data driven.